Check it.
Okay, welcome back. Today we're going to be talking about lesson 6-8, day 1, the rational root theorem. Now, up until now, we've learned a whole bunch of different ways to find the roots of a function, okay? And different ways to find information about roots. For starters, we learned this thing called the fundamental theorem of algebra. And the fundamental theorem is pretty simple. It just tells you that whatever power your function is, whatever degree your function is, that's how many roots you're going to get. So if it's a fifth power function, you're going to get 5 roots. Some of them might be real, some of them might be imaginary. They might all be real, they might all be imaginary. It depends on the function. So if you have a 10th power function, you'll have 10 total roots when you add together all the reals and all the imaginary complex roots. Then we learned about Descartes' rule of signs. Now, Descartes' rule of signs just helps us have an idea how many of each type of root we'll have, meaning how many positive real roots we'll have, how many negative real roots we'll have, and how many are 0. We can tell that from Descartes' rule of signs. But it doesn't tell us what the roots are. That's the thing. It doesn't give us the answers. It just kind of tells us there are going to be 5 real roots and 5 real positive roots and 2 real negative roots, that sort of thing. But it doesn't tell you what the roots are. And usually to find the roots, what we do is we factor. We get things to fully factored form, and then we set the factors equal to 0, and that's how we find the roots. And sometimes the degree of the polynomial is too high for us to do that, so I have to give you like a hint. I have to say, all right, let's say 5 is a root, and then you're supposed to take that 5, do synthetic division, and help you find the rest of the roots, so that help make it more factorable so that you can find the rest of the roots. Well, what if I didn't give you that extra number? What if I didn't help you out? Because that was sort of training wheels, okay? That was sort of me giving you kind of a hint that I'm not supposed to give you technically. So this next thing we're going to learn today is how do you find your own hint? How do you find your own training wheel, so to speak? And that's called the rational root theorem, okay? So I'm going to be giving you a function that you have to find the roots for, and what you need to do is use this rational root theorem to give you an idea of what kind of numbers you should, because it's going to be guess and check, but the question is, how can I put it this way? If you use Descartes' rule of signs and it says there's going to be 3 real roots and 3 real positive roots and 2 real negative roots, those numbers could be anything. It could be, 3 real positive roots could be 5, 3, and 7, or it could be 2,134,328 and 2. There's no way to know what those numbers are. So the rational root theorem helps us narrow things down by giving us a list that we can check, and we'll use Desmos to check it or a calculator to check it. So here's an example. I have here a 5th power function right here. Now, we definitely don't know how to factor a 5th power function. We have no idea how to do that. We could maybe try to do factoring by grouping, but I don't think that's going to be possible either. So usually what I do at this point is I say x minus something, I don't know, I'll make up a number, 3 is a factor. And you would say, all right, if x minus 3 is a factor, then c equals, it's supposed to be x minus c, so c equals 3. And you would do the synthetic division starting with that 3. But here's the thing, what if I didn't give you this? Can you find this by yourself? That's the question we're answering today. And, well, the answer is you can't go straight to knowing what it is, but you can make a list of possibilities. So I'm going to show you how to do that using something called the rational root theorem, okay? And we're just going to find the possible roots. We're not going to actually use them in this particular example. That's why it says do not check them. So here's how this works. The first number here, the first term here is called the lead term. It's the one with the highest power. It tells you the degree of the function. So x to the power of 5, that's the highest power. This is a 5th degree function. So the FTOA, the fundamental theorem of algebra, says we're going to have 5 roots. We know we're going to have 5 roots. And if we use Descartes, we can tell that it's going to have, let's say, no sign change, 1 sign change, 2 signs. It's going to have 2 positive, up to 2 positive roots, real roots. And if you make all the odd powers negative, that becomes a negative, that becomes a positive, and that becomes a negative. We'll have 1 sign change, 2 sign changes, 3, and 3 negative roots. That's the maximum. Okay, so we have 5 total roots. If they're all real, the most we can have are 2 positive numbers and 3 negative numbers. That's what we know from the stuff that we've learned so far. But what can those numbers be? They could be anything. They could be, like I said, 3 or 2 million. You don't know. So here's the thing that we're going to do here called the rational root theorem. We're going to take the last number here that has no x on it. That's called the constant term. And in the book, they referred to it as P. Okay? I'm not sure why they chose the letter P, but they call it the letter P. And you're going to take that P, and then you're going to look at the first term, the lead term, and take the coefficient of the lead term, which is 4, and we're going to call that Q. So you got P and Q. And what you're supposed to do is take all the factors of P, okay, take all of the factors of P, which is the constant term, the last number, and divide them by all the factors of Q. So in this case, P is 16 and Q is 4. But you're not dividing 16 by 4, you're dividing all the factors of 16, so 16's factors, by 4's factors. And here's the thing, it's got to be plus or minus for each one of these, okay? Because it's possible that it could be plus or minus. So let's do that. What are the factors of 16? Well, the factors of 16 are 1, 1's a factor of everything, 2, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. Now, those are all the numbers I can think of that go into 16 evenly. I don't think I missed any, right? And then for 4, the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. So that's the setup, okay? And that's worth 1 point right there. So now what you're going to do is divide, okay? And it's sort of like the heart method in the sense that you're going to divide all of these numbers, all of these, by 1 first, which obviously, okay, let's do that. So what do we get? What's 1 divided by 1? Hard question. It's 1. But once again, you're going to use plus or minus for everything. So plus or minus 1. So these are the possible roots now, possible roots. X equals plus or minus 1. You got 2 over 1 over here, so that's going to be plus or minus 2. You got 4 over 1, so plus or minus 4. And you got 8 over 1, so plus or minus 8. That takes care of dividing by 1. Now, we're going to divide everything by the next number in the denominator, which is 2. So now we're going to divide everything by the 2 here. So what do we get? Well, 1 divided by 2 is 1 over 2, 1/2. Don't forget your plus or minus. 2 over 2 is 1. Well, isn't 1 already on the list? If it's already on the list, it's a repeat. We don't have to do it. How about 4 over 2? 4 over 2 is 2, and 2 is already on the list here, so we don't have to do that one either. How about 8 over 2? 8 over 2 is 4. 4 is already on the list, so we don't have to write that down. And then finally, 16 over 2 is 8, and 8 is already over here on the list, so we already did that one, so we don't have to. In other words, there's no sense in writing repeated, redundant things. We know that those are already possibilities. So we'll go on to the last one now. We're going to take all these numbers and divide them by 4 now. All these numbers and divide by the last number in the denominator here. Okay, 1 over 4 is 1/4, plus or minus. 2 over 4 is 2/4, but 2/4 is 1/2 when you reduce it, so 1/2 is already on the list. Right? We already have it, so we don't need it. 4 over 4 is 1. We already have that. 8 over 4 is 2. We already have that. And 16 over 4 is 4. We already have that. So actually, that's it. That's our list. Okay, so we're done. And this is your answer. If you just want the possible roots, this is the answer. Now, let me be clear about something. This is called the rational root theorem. Rational. That means you're only going to get rational numbers with this process. You're not going to get square roots, okay, which are irrational. You're not going to get imaginary numbers, which are also irrational, okay, and not real, right? You're only going to get fractions and whole numbers. That's what rational means. It means fractions and whole numbers. So rational comes from the word ratio. And a ratio is a fraction where the top and the bottom are whole numbers. So this is a ratio, 3 to 4. You wouldn't have 3.7 over square root of 2. That's not a, no. You couldn't have any decimals or any kind of symbols. That's not a rational number. So, or even 1.5 over 3.2. Technically, that's not a fraction because, it's not a rational number the way it's written because it's not a ratio of two whole numbers. Now, you can do something to this to make it rational, but I'm not going to talk about that right now. All right. So, anyway, yeah, these are all the possible roots that are whole numbers or fractions. And now, what you could do is start plugging these into your function to see if they are x-intercepts. If you plug in a number up here in the function and it comes out to be 0, that means, let's say you plug in 1, for instance. If you plug in x equals 1 and y becomes 0, that's an x-intercept. That's a root. Bingo, you win. You found the number that you want to use to start your process with. Remember the training wheels? You found that. Okay, I thought I wrote it up there, but I didn't. So that's the idea. For this one, we're not going to actually check to see if they are roots. I just wanted the list here. Now the first, let's see, the homework assignment at the bottom here, 10 through 15, just find the possible roots. That means you're not going to actually do more than, you're just going to do what I just did here. Just find this list. But you need to show your work. So the work is set up this, find the factors of the last number, P, find the factors of the first number on the bottom, Q, do all the dividing, and make your list right here, and they should all have pluses or minuses on them. Okay, so for this next example, we're actually going to find those roots now. So not only are we going to find the possible roots like we did above, we're actually going to then use that information to find out what those roots are. So let's take a look here. What is our P? What is our Q? Remember, the P is the last number here, and the Q is the first number here. All right, actually they're supposed to be lowercase, but that's okay. And we're going to take the factors of P and put them over the factors of Q. So the factors of 6, and I know it says -6, but it doesn't matter what the sign is. You're going to put a plus or minus on it, over the factors of 1, okay? So the factors of each of these, not the actual numbers. We're not going to divide 6 by 1 yet. And this is the factors of 1. Okay, so what are the factors of 6? Plus or minus 1, which is a factor of everything. Plus or minus 2, plus or minus 3, and plus or minus 6. What are the factors of 1? Well, just plus or minus 1. And that's it. Now, we're going to do the division. So let's divide this, and you get 1 over 1, which is 1, right? So plus or minus 1. 2 over 1, which is 2. 3 over 1, which is just 3. And 6 over 1, which is 6. And you don't have any other numbers in the denominator, so you're done. That's it. So how many possible rational roots are there? How many things do you have to check? Well, there are 2 here, plus and minus 1. There are 2 here. So total of 8, right? 2, 4, 6, 8. So we have 8 possibilities. And if you were doing the first part of the homework, possible rational roots, this would be it. This would be the answer. But we're not, obviously this is an easy one. Why? Because we're going to actually do the rest of it now. So now what you do is you take your calculator and you have 2 choices really. You can plug it in by hand. You can plug it into a calculator. Okay, and when I say calculator, I mean calculator, not any sort of anyway. And you can, you can also use synthetic substitution, which we learned recently, to plug things in. But I think the simplest thing here is just to reach for a normal calculator. And you can put in, okay, this is x cubed. So we're going to check the number 1 first. So in parentheses, you put the number in parentheses, and then you put the power outside the parentheses. So 1 cubed plus 2 times 1 squared. We get -8. So that's not a y-intercept because the y is not 0. The y is -8. So that one doesn't work. And then you just press the up arrow on your calculator and you go back and change all those ones to another number. In this case, we could try -1 now. So insert a negative here, and then we hit enter. Hey, that one's a 0. That means -1 is a root, which means that x minus -1, which aka x plus 1, is a factor. Okay? And once you have one of these, all right, now you can do the thing that we were doing. So now you got your own training wheels, so to speak. You got your own hint. So -1. So you're going to do synthetic division now. -1 outside, and put down your numbers here, which are, let's see, 1, 2, -5, and -6. And we'll do synthetic division now. We'll drop the 1. This is going to be -1. 2 plus -1 is 1. That's -1. This is -6. And then 1 times -1 times -6 is +6. And this is a 0, as we expected, because we knew it was a factor to begin with. So what do we get? Well, when you, I haven't used this word in class before, but when you take a function, in this case is a third power function, x cubed, and you do synthetic division, it comes down 1 power to x squared. This process of moving it down a power is called depressing it. So you're pressing it down, so to speak. So this thing that you get, this answer you get, which is now, this is x to the first, this is x to the 0. You're going to get 1x squared, or just x squared, plus 1x minus 6. This is called the depressed polynomial. Okay, it sounds like the polynomial has no friends, but it just means that it's been brought down a power. Okay, and so now you have a factor, which is the one we found over here, x plus 1, and you have your depressed polynomial, which hopefully you can also factor. Can we factor this? Does that look factorable to you guys? I think so. Reverse FOIL perhaps? Put down your x's and see what you can do here. Are there 2 numbers that multiply to give you -6 that add to give you 1? Yeah, 3 and 2, right? As long as the 3 is the positive and the 2 is the negative, this will work. And there you go. There's your f of x in fully factored form. Okay, there's your fully factored form, which is always our goal. And we're going to set all these equal to 0, because if y is 0, then all the factors can equal 0. And we'll use a zero product rule. And that means our roots are now x equals -1, which we already knew because we got it up here, x equals -3, and x equals +2. And there you go. And by the way, are all those numbers on the original list up here of the possible roots? Yeah, they are. If you had checked all of these, you eventually would have gotten all 3 of these. But here's the thing, this is only rational roots. So if you had any roots that weren't rational, that weren't, if you had any imaginary roots, they wouldn't show up by doing that. So you still have to factor and solve, but at least you can find the rational ones with this list here. All right, let's try another one. So on this next one, it's going to get a little more complicated. I'm going to go to a 4th power function here. And since this is a little more complicated of a function, typing it into the calculator could be a little tedious. So I'm going to suggest that you use Desmos to plug instead of a calculator for this. Now the Desmos app is free. It doesn't do all the work for you. It's just a calculator, a graphic calculator. So yeah, you can try this, try Desmos for plugging in stuff. It's actually really, really quick. It's actually going to be a lot faster than what I just did. So we're going to do the list of possibilities here, and then we're going to have a pretty long list, well, not a really long list, but a longer list than we had before. And then we're going to use Desmos to check which ones are 0. And you're going to see it's a lot faster. So if you have access, you all have a laptop, so you can go to the Desmos website. If you click on this lesson plan here, I've put a link here and actually put one up here. It says Desmos page for all examples. I've already typed in the functions for you. So if you click on this, you go to Desmos and it will have the functions there already, or type the functions in yourself. It's not that hard. Okay, let's do this. Let's find the possible rational roots first. So our P rather, our last number is 18, and our first number Q is 1. So we're going to have the factors of 18, okay, the factors of plus or minus 18 over the factors of plus or minus 1. What are those going to be? Well, it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or 4 doesn't go into 18, 5 doesn't go into 18, plus or minus 6, plus or minus 9 times 2, and plus or minus 18 itself, all over plus or minus 1. And luckily there's only one number at the bottom, so you don't have to do any real dividing. Basically the top list here is your list of numbers. Okay, that's it. Those up there. So if I want to be really lazy, I can just copy that and stick it over here, because that's literally what it is. It's just the same list there. Okay, there it is. Okay, so this is our list of possible roots, possible rational roots. And we want to check all of these. We want to check 1, 2, 3, 6, 9, and 18. So we're just using, here's the function, and we're just using this box down here. Let's put in 1, see what we get. 1 is not a y-intercept, we got 16. -1. Hey, we got a winner, -1. What about 2? Hey, look at that. 2 works. How about -2? No. 3. 3 works. You can try -3, it's not going to work. Wait, -3 just worked. All right, so we just found them all. All right, if I go back to here, okay, if I go back to here, we just found out that x equals -1, x equals, I think it was 2, 3, and -3 are the roots. And this is a 4th power function. Fundamental theorem of algebra says you can only have 4 roots. And thus they were all on the list, and they were in the beginning of the list, so we didn't have to go through the whole list. But if you're using Desmos, this is a really quick process, right? You don't have to sit there with the calculator and type everything in. We can fully factor our function if you want to, which is, you have these things here, so it's x minus, x minus, x minus, and x minus. So if you want it in factored form, it's now this thing right here. What you get is this. So we actually already finished the problem here. This next one here, it says find all of the zeros, real and complex. Now I'm giving you a little hint here saying that some of these are going to be imaginary, which means they won't be on the list. This next one, we're not going to be able to just use Desmos for the whole thing, but we can use Desmos to get started, the training wheels thing, right? So here we go. We have 24, -24, and 2. So what are the factors? I'm going to jump right into the process now rather than all the P and Q stuff. What are the factors of 24? 1, plus or minus 1, plus or minus 2. There's actually a lot of factors of 24. Plus or minus 3, plus or minus 4. 4 goes into 24. plus or minus 6, plus or minus 8, plus or minus 12, and then finally plus or minus 24. And then what are the factors of the first number? Is 2, so plus or minus 1, and plus or minus 2. So those are the, the factors of 24 divided by the factors of 2. And now you need to divide. Now the first 12 factors are just, the first group of factors are just these because you're dividing by 1. And now I have to do all of them divided by 2. Well, what's 1 over 2? It's 1/2. So my next one here is going to be the fraction 1/2 plus or minus 1/2. Then I have 2 over 2, which is 1, which is already on the list, so don't worry about it. 3 over 2, which is a fraction, so okay, 3 over 2. 4 over 2, whole number 2, which I already have. 6 over 2, which is 3, already on the list. 8 over 2, right here, already on the list. 12 over 2 is 6, already on the list. And 24 over 2 is 12, already on the list. So here is my list of possible candidates here. So I have this function labeled as s of x on Desmos. Okay, and now I can just plug stuff in here. Let's put in 1, negative 20, no good. Let's put in negative 1, negative 40, no good. So 1 and negative 1, no good. How about 2? No good. How about negative 2? No. How about 3? Hey, we got a winner, 3. So we come back over here. X equals 3 is a real 0. We can keep going. How about negative 3? Nope. How about 4? Nope. Negative 4? Negative 4? No. 6? Negative 6? No. After 6 comes 8. Negative 8. Also no's. Then after 8 was 12 and negative 12. Nope. After 12 was 24 and negative 24. Nope. And then we had the fractions. We had, what was it, 1/2? Nope. And negative 1/2. Nope. And then 3/2? Nope. And negative 3/2. Okay, so the only root we got from the rational root theorem that actually worked was 3. We only got one root. And that's fine because we only need 1 to get us started. We only need 1 for our training wheels here. So we're going to take that 3. We're going to use synthetic division. We're going to find the rest ourselves. We don't need no stinking Desmos. All right, here we go. So what are the numbers we put in for the synthetic division? 2, negative 6, 8, negative 24. Drop the 2. 3 times 2 is 6. This becomes a 0. 3 times 0 is 0. This becomes an 8. 3 times 8 is 24. And this becomes a 0 as we assume it would because we already know that this is supposed to be a 0. So our original polynomial was a cubic, third power, and this is a second power. The depressed polynomial is 2x squared plus 8. So what's our factorization so far? So far we know that x equals 3 is a factor. So x equals 3 is a 0. So x minus c, x minus 3 is a factor. So we have this function is called s of x. So s of x equals x minus 3, that's the factor we figured out with the rational root theorem. And then after we synthetically divided, the depressed polynomial is this here. And this cannot be factored, okay? But you can solve it and get your imaginary complex answers. So let's do that, okay? So we're gonna, what you're doing here is you're making y 0, and then which allows you to set each of these equal to 0. You know you're going to get x equals 3 here, which we already knew. But what about this 2x squared plus 8 thing? So here we go. 2x squared plus 8 equals 0. You're going to subtract 8 from both sides. You get 2x squared. You're going to get 2x squared equals negative 8. You're going to divide both sides by negative 2. You get x squared equals negative 4. Now you square root both sides, and you can see you're square rooting a negative 4. Square rooting a negative, you're going to get imaginary numbers. So you square root x squared on the left, you get absolute value of x. You square root negative 4, if you remember how this works, this is 2i. You drop the absolute value bars, now you have plus or minus 2i. And of course, you're supposed to write this in a plus bi form, so you put a 0 here. So it's 0 plus 2i is one root, and 0 minus 2i, that's your other imaginary or complex root. So we have 3 roots here. X equals 3, x equals 0 plus 2i, x equals 0 minus 2i. And those are your 3 answers. All right, so if you're in the academic class, you're done. This last example here is for the honors class. We have our P is 4 and our Q is 9. So the factors of 4 will be plus or minus 1, plus or minus 2, plus or minus 4 on top. On the bottom, the factors of 9 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 9. we're going to divide all three of these by each one of these. Dividing everything by 1, we just get, now we divide everything by 2. Well, 1 divided by 2 is 1/2. 2 divided by 2 is 1. That's already on the list. And 4 divided by 2 is 2. That's already on the list. So we don't have to write anything else there. Now we're going to divide everything by 3. 1 divided by 3 is 1/3. Then 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. Write that down. And now finally, we're going to divide everything by 9. And now we have our list. So, okay, this is t of x. So let's go over to Desmos. All right, so let's try 1 and -1. 1, nope. -1, nope. 2, nope. -2, nope. 4, nope. -4, nope. So let's try 1/2, nope. -1/2, nope. 1/3, nope. -1/3, nope. These are even powers. That's why all my negatives and positives are coming out the same, because when you have even powers, it doesn't change anything. So I don't need to even try the negatives. So 2/3. Hey, bingo! What do you know? 2/3. And that means, by the way, that -2/3 should also work because it's an even number. Yeah. So we got 2 roots right there. So we're going to go back to here. We know that x equals 2/3 and x equals -2/3 are 2 factors. So what we're going to do, we know that we have x minus c for each one of these. And one is going to be x minus 2/3 and one is x minus -2/3, which is x plus 2/3. And now the question is, what's the factor left over here? And apparently it's not going to be rational because we tested all of the rational possibilities. So whatever we get in here is going to be either imaginary or irrational. So here's what we're going to do. We're going to take x equals 2/3, divide by 2/3. The numbers that you're going to put in for synthetic division are 9, 0, 5, 0, and -4. And here we go. Synthetically divide, drop the 9. Okay, so our depressed polynomial, we started off with the 4th power. So this must be 9x to the 3rd plus 6x plus, sorry, 6x squared, 9x plus 6. Now we know that -2/3 is another factor. So we could do this again now with the -2/3 and use these numbers now. 9, 6, 9, 6. So this was x to the 3rd. Now this is x squared. So this is going to be 9x squared plus 0x plus 9. So we just get 9x squared plus 9. This is going to be x minus 2/3, the first factor we found. Then the second, 2/3. X minus -2/3, which is plus 2/3 here. And then this is going to be 9x squared plus 9. Okay, and now you can set all these equal to 0 to find your roots. Now we already know the answers to these. This one's already established as x equals 2/3. This one's already established as x equals -2/3. But what do you get for this one here? So 9x squared plus 9. Well, subtract 9 from both sides. You get -9 there, right? Divide both sides by 9. You get x squared equals -1. You square root both sides. And now you got the square root of -1 here. That's the definition of I, if you remember it. That is literally I right there. So you get x is plus or minus, well, when you drop the bars, you get plus or minus I. Or the correct way to write that is 0 plus and minus I. So x equals 0 plus I, x equals 0 minus I, and there are your 4 roots. And for the second half of the homework, you have to go all the way. So for the first half, the first few questions, just give me the list of possible roots. For 9 through 25 odd, you're going to actually, use those roots, plug them into Desmos or a calculator, and use them to do the factoring like I just did here. Okay, we're done. See you at the next video.
Check this.